Hello, everyone. This is PyDataVE, and today there will be two special guests, two entrepreneurs in our sector. I am Alessandra, PyDataVE leader, and I'd like to explain who we are. PyDataVE is one of the local PyData groups. And who is PyData? It's a educational program of non-focus non-profit charity. And PyData organizes events, workshops, and hackathons for the data science world. And the mission of non-focus is to promote open practice in research, data, and scientific computing by serving as a physical sponsor for open source projects and organizing community-driven educational programs. So there are sponsored projects by non-focus, like Pandas, Scikit-learn, Matplotlib, and there are affiliated projects that are not physically sponsored but by non-focus, but they can access to community, certain funding opportunity, and promotion through non-focus network. Some examples are CPython, Gensim, and Polars. So our goal is to share about open source projects and experiences of technicians in the data science world. Okay, I've talked too much. Now I let our host, Sara Ferro, speak. And,
So, hi everyone, I'm Sara Ferro, and I'm a collaborator of Alessandra. And we are currently sponsored by Corley for the streaming, but we are still waiting for more sponsors. Indeed, we are searching for more. So if you are interested in, let's contact us. If you have any proposals or suggestions about the topics that you want to talk about that include data analysis, let's contact us. So you can use this QR code to be redirected to a form that you can fill with your suggestions. And the agenda for today is to have these two fantastical speeches from our guests, and then we will talk about the next meetup, and we will go to do a bit of networking after. The first speech is by Rosilari Bellacosa, who is a CTO of SignDug, and she will talk about how she uses her knowledge about AI with her application, and so she will introduce the application in medical data. And yeah, so I leave the floor to Rosilari Bellacosa, and we are happy to have her here.
Thanks a lot, Sara and Alessandra, for having me. I'm quite happy to be here tonight. And so basically today we're going to discuss a real-life application of AI in healthcare and especially in the FemTech industry. So before starting, just a couple of words about myself to introduce myself. So I'm Rosilari Bellacosa, and I'm now CTO at SignDug, a company that I co-founded in 2018, I believe, with two other people, Daniele and Federica. I wasn't always in the tech industry because I started as a neuroscientist, and I used to study the visual system both in humans and in rodents. And then I switched from visual neuroscience to computer vision because at the time that was a straightforward switch, no joking about it. And so I co-founded Syndiag, and I first started as R&D director because that was closer to the job I had before in academia, and then I moved to the CTO position. Coming to Syndiag. So Syndiag is a startup company. We apply artificial intelligence to imaging for diagnostic. And we launched our company in 2018 as a spin-off of Politecnico di Torino. And since then, we've come a long way, as people say in this field. And so we now have other 9 people working with us. And this year, we just hit the market with already showing some traction. And that's the thing I'm most proud of, to be fair, because it took quite some time, to build all this. And I'm always quite happy to talk about that. And so we are in the field of computer vision applied to imaging and diagnostic. And this is one of the most popular, I would say, application of AI in healthcare, also because it comes from a long tradition of computer vision in applied to imaging. But there are also other things that you can do with artificial intelligence in medicine. Of course, predictive analytics, very popular at the moment, although still R&D phase to me. In personalized medicine, we can use generative AI to generate synthetic data to protect patients' privacy during clinical trials. We could optimize workflows in hospitals and their processes. We do not do that. I don't know why, but we can do that, and so on and so forth. And all these applications, of course, have their own, merits, and they bring some value to the clinical industry, to the medical industry. And a couple of weeks ago, I was invited to a conference, and the host there asked me, what's the benefit of applying artificial intelligence to healthcare? And I said to these people, well, of course, any startup you're going to talk to, they're going to say that, we increase accuracy, or we speed up times in anything, or we cut costs, we're amazing at cut costs. But talking about benefits, those are metrics, of course, and those are good metrics, but we're not sure if any of this is actually improving any of the jobs in the medical field. And this because the metrics that you use to explain the benefits that you're bringing is going to be consistent with the task that you're trying to solve, and especially with the problem that you're trying to solve. So think about, AI application as a continuum that goes from no AI at all to full automation of the solutions. So no AI at all means that applying AI to a process wouldn't actually add any specific value to anyone. So one typical example is trying to replace a therapist in a clinical therapy setting in psychology. That wouldn't make any sense, okay? Because most of the job is made by the relationship. So in that case, you wouldn't apply AI, even though maybe you're great at developing a chatbot that acts better than the average psychologist. That wouldn't bring any value. On the other side of this continuum, you have a condition of full automation in which you do not have any, doctor at all, but just like AI application. And when do you have full automation? Well, in all those cases in which automatizing a task means that you're basically doing something that doesn't bring any value to the doctor. So this means, think about the classical example here is the breast cancer screening that creates loads of imaging data every year. Most of those images, luckily, do not contain any valuable information because the patient is healthy, and this is great, but the radiologists always have to take some time to still analyze and check all those images. Well, this task can be easily done by an artificial intelligence, okay? So in this case, for example, it makes sense to measure accuracy because we want a system that performs better than the average radiologist in the same task. And then the radiologist can focus on the small amount of data that instead need all the expertise and all the attention by the doctor. But most of the solutions that we see in the market, also because it's easier from a regulatory point of view, they actually fall in behind in the so-called clinical decision support field, which is AI assistant. So we are developing a system that sees some sort of interaction with the doctor in this case, okay? And so the idea is that we're doing something that improves the overall and daily activity of the doctor. So anything that we're building should be consistent with our promise that we make to the doctor that we're going to make his or her job easier. So we're going to add some value to their daily practice. And so that's basically, I mean, that was pretty easy to understand what we're doing with Syndiag. And so we started from ultrasound and we apply computer vision, so artificial intelligence to ultrasound. Why we chose ultrasound? Because this is a very widespread technique. And at the same time, it is strongly user dependent. This means that the ability to see anything in an ultrasound image depends a lot on the expertise of the person that's making the examination. So this is like a classical application field for AI because we have a task which is extremely variable when it comes to human, and we introduce a tool, which is a math tool, that is going to make it more objective, more reliable, and repetitive. And so we started from a very specific use case, which is the ovarian cancer. Ovarian cancer is the typical example in which you have low incidence, so not great chances for a doctor to develop expertise, and at the same time, high mortality rate because it's diagnosed with ultrasound, and non-expert doctors pretty often miss all the elements that are needed to make an early diagnosis. So that's why we decided to start from this specific case to develop a system that is able to interpret the ultrasound image in order to provide to the medical doctor all the elements that then the doctor is going to use to make the diagnosis. So again, support, clinical decision support system. So this is like an example of the interface of the tool that we developed. So we take as input both images and videos. And what we do is we've developed a navigation system, let's call it like that. So a system that is able to see if there is a tumor or not within the image that we're presented with. And then with this, if there is a tumor, we're going to segment it and extract all the relevant features from it. All those features are clinically relevant features, so things that the doctor should be able to see in order to, go on with the diagnostic process. We all show everything to the doctor in a visual and transparent way, and then we use all this information to propose a diagnosis, which is the correct identification of the tumor. So we do not just say just benign and malignant, but we also say, okay, it's benign because it's a fibroid, which is like a type of tumor, ovarian cancer. Okay. What's under the hood of this system here? So we basically have two main functions here, two main features. One is the visual tumor description, which is the one that creates the color map that you've seen before. And the other one is the diagnostic suggestion. So the part that also takes this information and uses them to predict a possible diagnosis. Those two things are separated because they undergo different regulatory options. We take all this information and we bring it together inside a so-called ultrasound report, un referto medico, which is a very actionable item because it's the thing that the doctor uses to communicate with the patient, to inform other colleagues, to inform the hospital, and so to start the therapeutic journey, if needed, of course. So I believe that in order to provide a system which really acts as a support system, there are two pillars that best describe what we're doing. One is transparency, and the other one is modularity. And I'm going to explain myself. So when we think about the very first application of AI in healthcare, but in any other field, we think about input, something black box happens, output. We always have to put ourselves in the shoes of a doctor, which is not an engineer, okay? And so in this case, this system is completely black box. We do not understand why the network is telling me malignant or benign. And things are okay as long as we are in a complete automation setting, like the breast cancer one that we described before, because in that case, we do not really care what's going on. We just need, the images to be selected. But in the case of us trying to provide extra information to a doctor that wants to, to make the diagnosis, this black box system wouldn't give much of a value, right? Especially in the cases in which the model and the doctor disagree, because the doctor won't have many information to try to understand why the network made a mistake. So it's also hard to relate to the system. That's why people have tried to implement what is called explainable AI. One example, classical one that you see depicted here is GradCam approach. In this case, what we're doing basically is we're trying to highlight all the features, which are high order features that were developed by the neural network in this case, that were most responsible for the classification output of this network here. But again, a system built by engineers for other engineers, because in this case, these features they describe the solution, process of the network, but they are not, those features are not clinical features. So they do not have, clinical and medical names. It's pretty hard to relate with this. And so it's not extremely useful, right? In this case, what they're telling us, what we see is that, okay, background doesn't mean a thing because it's blue. And the area that we're taking into account to diagnose a tumor is the tumor area. So, it's quite redundant, isn't it? So that's why we try to, we started from the same approach, so extracting features, but we tried to do by trying to extract clinically relevant features by design. So what we did was taking real data from real ultrasound, like the ones you see on top. And then we took the official diagnostic guidelines, the international ones, that all the doctors know by heart. So any doctor, any gynecologist knows those guidelines. What's the hard part of the task here? Being able to recognize and to measure them and to estimate them inside the medical imaging, so inside the ultrasound. And that's what we thought our systems to do. So we built an expert gynecologist that is able to extract those relevant features, okay, those guidelines. And that's the output that we're giving to the doctor in our design, in the design of our product. So in this context here, the output that you see is pretty visible. This means that the doctor can also disagree with it. So for example, the red spots at the bottom, me as a gynecologist, I could say, okay, I mostly agree with you, but I think that the red spot on the top in there is just an artifact, I wouldn't count it. And so I correct the output of the system as well. So to me, it's also a way to interact with the system in a way that makes some sense. We then take these features that have been extracted and we use them to feed the second part of the algorithm, which is the one that identifies the tumor. So it tells me, yes, it's benign because it has these features and it's a fibroid, for example. Of course, transparency, it's something that we're talking about a lot at the moment because it's one of the pillars of responsible AI, and responsible AI is one of the pillars of the AI Act and all the regulation that we're seeing at the moment. So we need to be transparent also for regulation issues. And second pillar of this system that wants to be as usable as possible for the doctor is the modularity. So modularity means that each step, okay, of the pipeline is a single module. These single modules have been trained singularly and also can be deployed singularly somehow. This means that according to the setting I'm going to deploy the product to, I can choose what output to provide to the doctor. Because my gynecologist, which is like normal gynecologist, she's not an oncologist, she's not going to need the tumor identification because she's not the one that is going to perform the surgery on me. She just wants to know if that thing that she sees might be benign. She might want to see possibly the features that are inside it just to be sure and to follow up me, or she may want to send me to the oncologist. Whereas the oncologist, which is the one that is actually planning to do the surgery and the therapy to me, might want to have some confirmation about the tumor identity instead. And so it's going to use the entire product and all the modules. Having a modular system, so we're actually customizing the output, and this brings value according to the people that are going to use it. And another, good thing, another pro of modularity is the fact that we could develop each single module with less resources. And so this means that we could use less data for each task, and we could also we're a startup, so limited resources. And so we could plan also the deploy of each feature in a product plan that we could see in advance. And so, also sustain from an economic point of view and also from a development point of view. So there are several, positive things about having modularity. And by the way, this approach really translates also to the new way of doing AI, which is having a foundation model and then having fine-tuning for all these specific tasks. So modularity, however, of course, we all know that also has some cons, which are especially from a technical point of view, but also from a performance point of view. So how are we going to measure the performance of the entire tool that we are developing? And this is extremely relevant because, of course, the regulation affairs from European community are going to ask me about this. And so I just want to show something in terms of an approach that we can have to interpret the performance of the single modules, okay? This is not going to be definitive because we as well are still developing some parts of the product, but I mean, just to give like a framework that for us is working. So for example, let's just take a look at the segmentation task, okay? Segmentation task, pretty easy, pretty straightforward. How do we measure it usually? IOU, dice, so we use like overlapping measurements, okay, which are pixel-wise. So we really care about these single pixels. But we can actually interpret the segmentation module, so the segmentation task, as 3 different stages. So we have a first stage, which is classification, where we are able to spot any mask, to predict any mask, any segmentation at all. There is then a second task which we can actually use, which is detection task. And this detection task means, okay, I was able to find a mask, a predicted mask, and in this image, there's also a ground truth mask. So do they overlap? If they overlap, I'm actually having a detection because more or less I'm finding, the position of the object that I'm interested in. Segmentation with the IOU and dice instead is more like tells us how good we are at spotting exactly the tumor and just the tumor within the image, okay? So these things can actually overlap with the tasks of the modules that I've described before. So classification can describe our navigation task. Detection can describe our, ROI detection part, so the part in which I create the colored mask, whereas the segmentation task, so the real segmentation part, is not extremely relevant for the doctor because the doctor doesn't really care about pixel-wise segmentation. I mean, I would love to show you some, measurements that they take. There's so, there's huge range of variability, but this an important segmentation, so an accurate segmentation might be extremely relevant because I'm actually feeding this information to the next module, which is the one that is going to extract the features from the tumor that I'm going to then use to identify the tumor type. So it might be extremely relevant for me to have a system that both can give me like a good detection, and then I could stop quite easy, right? Because I just need an IOU of, 50%. But then I also need the system to perform very well because this is going to be a part of a pipeline. So this is a way of describing this type of results. So I'm having here sensitivity and specificity because I'm in a clinical environment kind of approach, but you can also have accuracy there, whatever measurement you like. So we're actually now trying to transform our IOU, which is a continuous measure, into a binary measure here. So sensitivity and specificity, are measured based basically on false positive and false negatives. And so I've plotted them against the IOU. IOU is the measurement of segmentation, so how good I am with segmentation. So on the left, we have no overlap at all between the predicted mask and the ground truth mask. On the right, I actually have complete perfect overlap, 100%. This means that all the pixels are exactly where they should be. And if we actually compare this with what I said before, we might say that for navigation, even a small overlap might be interesting for us, okay? So we might think that with a small overlap, we already have high sensitivity and specificity. So we might say, okay, navigation, we're good at it. In the middle, because again, IOU is on the x-axis, in the middle, we might have, detection task, because again, I need somehow a bit of overlapping between, the predicted mask and the real one. And so I might fall between the range of 0.5, 0.75 IOU, so like a medium-sized IOU, just to give this information to the doctor. And for feature extraction, I might be interested in knowing my sensitivity and specificity in terms of very high IOU, so a huge overlap, okay? Because, for example, in the last case of feature extraction, if sensitivity is pretty low, this means that I'm making, quite false alarms. And so this means that maybe I'm actually extracting features from parts that I am recognizing as a tumor, but they're not a tumor. So I need to be really careful there at the end. And this tells me that I still need to work a bit on this model if I want to step to the feature extraction part of it. Just to close, because it took some time. How did we develop this solution? So we started from 800 clinical cases. We actually have much more than this, but 800 is the conservative estimate in terms of the real clean data that we have, all complete, amazing. And this is quite a data set, and it's quite unique in the field. So, we took like almost 4 years to build it, so we're very proud of it. And this is like the tumor distribution. So in green, you got benign ones. In orange, you got the malignant ones. In blue, there is something which is in between. They're called borderlines. And each slice of the pie is actually a tumor type. So these are 15. Ovarian cancer can get up to 40 tumor types, but most are pretty rare. So these are like the most common ones. And this solution is very easy and straightforward with a very light tech stack. So Python, basically most of it. Of course, I'm talking about the AI part. And we started with TensorFlow, we then switched to PyTorch, and the models that you've seen are consolidated deep learning solutions. UNet is still state-of-the-art segmentation in the medical field. And we fine-tuned the models by building our own little cluster on AWS Batch, and all the simulation were orchestrated by using GitLab and web devices, although we're now switching to Metaflow, I'm not sure. And this is just like a brief overview of the architecture of the product in this case, so the way that we deploy these models. If you're interested in any of this, I mean, I took already too much time, so we can discuss about it later on. And thank you for your time. And if you got questions, I'd be super happy to answer.
So anyone from the guys that we have here have any questions, and somebody online?
Yeah.
For curiosity, only two questions. I mean, I'm a little bit curious. You use 800 inmates, or when you
cases, clinical cases. So each clinical case, so this means basically that each clinical case comes from a patient, a specific patient, but we actually collected several images and videos and anything from a single patient. So the numbers get quite up, much higher. Yes, a clinical case means that basically you actually have that specific patient. So 800 different patients and several images for each of them.
If I didn't get well, you said you have a guy, you have this specialist oncologist and gynecologist.
Yeah. Those are like those.
So they are doing the annotation, or?
They're doing the annotation. I mean, okay. So we implemented some sort of like, okay. So you can, I mean, we tried anyway to have doctors annotate their own data. I mean, we tried, like, I mean, I cannot say anything because we're like streaming at the moment, but we tried everything. But so what worked at the end, it was review processes. So we had like people taking, like being onboarded on the task and being, instructed to do the task. And then we took like, we basically stole hours from our doctors to review all the annotations. Most annotations also come from metadata, which also come with the clinical case, because we also take, together with the images, we also take data from ultrasound report and medical report. So all those information also guide and infer the annotation process. But we actually had strong review process, and we even have a scientific board now that does the job for us, so the reviewing part. But you cannot, I mean, doctors are not going to annotate anything.
So they don't have any issues they argue on the annotations, or?
When they had like, they had confrontations in this reviewing process. So in some cases, we ended up totally changing the annotation that we made. So there was a case in which we totally like missed the tumor. We were segmenting something else, for example, and they changed it, of course. And we actually have a very strict pipeline because all these things I also need to communicate to the regulatory bodies and so on and so forth. I mean, it's all documented. And so the idea is basically that there's one datum cannot be added to the R&D stack unless it's been reviewed. And this is very strict because otherwise you end up, like confusing. And to be fair, we even started, like when we started in 2018, we had like a data set which was annotated by us with some help from some doctors. And we didn't really get why the system was, and we couldn't train basically the network, so it wasn't learning. And then we started working a lot on data set, and performance started, increasing a lot. So I mean, that reviewing process was very relevant. So I mean, yeah, we're gonna stick to it. And yeah. But I mean, also unsupervised system approaches are quite useful because I mean, annotating all those data, it took ages sometimes. So yeah.
But do you think they are willing to use this tool in their daily work, or
we're selling
what
it?
do you think?
We're selling it. We're selling it. We actually had like a quite an interesting contract last year that was worth it like 750K. And so yeah, people are buying it. So I mean, yeah.
Most of the time, non-technical people, they are reluctant to accept this type of solution. That's why I'm asking.
We can actually discuss this later on because I mean there are several aspects to it, and one thing is that AI is extremely cool now.
The ethical part they don't want to accept because it's against the.
They're using it to show that there are innovative people because there's huge competition among private clinics. And so if you have AI, you're a better private clinic than the one that's on your side. So that's one thing for buying it. The other one is that actually they have this issue. I mean, the problem they have, it's something that we learned in the hospitals talking to doctors. So I mean, this problem in interpretation, it exists. So I mean, they would like to have it solved. The real problem here that we're seeing that really creates frictions in the implementation of this method is the fact that it's extremely hard to share data from the ultrasound machine or from anywhere in the facility to the system. That's this gap here. And it's something that we're trying to, we're trying to make the system as automated as possible. But it's not always possible because, of course, I mean, public hospitals, they do not want their data to end up on American clouds. Okay, on clouds in general. Pretty often, you don't even have a protected internet connection in these places, and sometimes the ultrasound machine is not even connected to the network anyhow, and you'll need a technician from the specific brand to come into the hospital and make the connection. So, I mean, system integrators, they have so much work to do, and so yeah, going back, I would do the system integrator.
One last question.
Yeah, sure.
You re-input dataset. I mean, you convert the image from the ultrasound to.
We take DICOM format. Okay. DICOM format is the standard format for exporting healthcare data, and they come with. So you actually have like the media data, so it's either an image or a video or whatever, and they also come with all the metadata which are associated with the examination and the machine itself. So that's pretty useful. That's the standard of doing this. Thank you.
Okay. Any other questions? I think online we don't have any questions. Okay, so we go to the other. Thank you, and we go to the other speaker. Lorenzo Pinosa.
Hi.
So he's an entrepreneur, and he will explain us how he uses AI tools in order to improve his coding productivity and his efficacy in software development in general. So I am happy to give the floor to Lorenzo. So have a nice.
Thank you, and thank you for having me. And today, as she told, I'm speaking about AI and coding productivity, and I will share some tips and tricks that I use every day to help me in my work. Before starting, just a few words about me. I'm Lorenzo Pinosa. I'm a computer engineer specializing in artificial intelligence since 2015. And now I'm here in Venice, and I belong to the Order of Engineers here in Venice. I started with the master in Politecnico di Milano, Then I had an experience in a big company, a multinational company that now is called Entity Data. I bet you know it. And I started in the AI team. So we did a lot of AI-focused projects because we were the center of excellence in Italy for the AI projects. But the real thing is that we did the full stack development, and I was responsible of designing cloud architectures because in big companies there is not that much time to do real research and development. That's why after earning myself some certification for cloud architectures and having some AI lessons, I switched to Argo Vision. That was an ex-startup. And here I had a really good time being able to specialize myself in tailor-made AI models. And we trained a lot of tailor-made AI models, especially for edge deployment, so mobile deployment and IoT deployment. And even in this experience, AI was not the only field of experience, because we had to made that AI models available to the companies that asked them. So I developed SDKs, including those AI models in Swift, in Kotlin, and so on. And I also had the chance to have some AI lessons in the Pavia University and for a master. So that's also a thing that I like to do. And since 2023, now I left my job, and I am an entrepreneur and AI engineer, and I am both developing projects for companies and thanks to the experience, the full stack experience. I am also offering myself as a CTO for startups, but the main things is working on products that I hope to announce and launch soon. So I'm quite busy in different projects, and I hope that what I'm telling you today can be useful. So before starting, some words on meta productivity in the sense of how to use AI. I really like the speech before mine because I definitely agree that the AI is wonderful to automate things, but what should we automate? How should we automate? And in my vision, AI is not worth it unless you are starting from a fine-tuned and high value-added process to automate. And this is the very starting point. So my first advice here is to start using AI, but be always critical, and I will elaborate about this later on. And so first advice, always lead a conversation, because LLMs right now are really eager to give answers, to suggest solutions, and they do not plan enough yet before giving answers. So always start asking the AI to plan together what to do and to reason together with the AI to accomplish your goals. And we hope that O1-like models that are coming that are trained to implement a chain of thought, that is, before giving an answer, start with a very long, and I will show you some example later. Start with a reasonment process. We hope that those models can help in this. And so this is what I have already told you. So to avoid local optima, the really first thing is to plan first. So you really have to ask it to AI, do not write code yet, please. Just align all the possibilities, wait for my confirmation, and let's plan it together. So be critic, and as hallucinated as always possible. I had a lot of cases of this, and I remember about one thing in particular, that the AI made a really good catch and a really good suggestion, and I gave it for granted. and instead I wasn't able to debug it, and until I found the point that is the method that the AI suggested wasn't the right one. But it was compiling, but there was a small, really hard to debug problem that caused an error. So be critic and also try to be able to spot suboptimal answer. And this connects to what I was telling you before. You have to start from a process, start from an experience, start from a know-how that belongs to you, that makes you able to understand if, or at least to guess that the answer the AI is telling you, is giving you, is not the optimal one. And to help you in this, also, I suggest you to ask a lot of follow-up questions. I will show you this in practice just in a few minutes, and compare. Submit the question to different models. I will show you later how. So you can analyze pros and cons of each answer, and work with the many different models to be able to understand which model is better in which task. And to end this must of personal productivity tips, always understand the AI generalization ability. So please always remember that the AI still isn't AGI, so it always has its limits. And remember that machine learning is learning to do things without being explicitly programmed. So the AI had to abstract concepts from the training set. And also remember that the size of models have an influence on quality of the responses. So today, the smaller models have smaller capabilities. For sure, we didn't hit the limit, but today we can still feel it. And this paper, I think, is really worth a read. An Apple paper that is trying to understand the limitation of reasoning in LLMs. So I will show you a bit of this paper. Okay, because while I was preparing this talk, I was also thinking about presenting you some models that can be maybe be run directly on your laptop and so on. But I wanted, in my opinion, such small models are still not enough to help. But later I will show you an example. The main point of this paper is that they started from JSM 8K, that is really a standard benchmark for LLMs to understand how they are doing on math tasks. And they try to change the dataset and to understand what happens to the performance of the models. And they changed it, and they saw that the performance were going down. The performance was going down. And it's important to see the distribution. The performance was going down the most for smaller models, 2 billions, 2 billions, 9 billions, 7 billions, and so on. And bigger models like O1 Mini or GPT-4o had a really a little performance hit for this. So they said, okay, let's do even harder benchmarks and to really test the abilities of the model. Even benchmark that you would say this really shouldn't hit the performance of a model. The GSM no-op is a dataset which just added some phrases to the task that were useless to accomplish the task. Let's see if, yes, there is, here is an example. So Oliver picks 44 kiwis on Friday, and so on. How many kiwis does Oliver have? So a sum is asked. And this no hope phrase sentence was added, but 5 of them were a bit smaller. So this shouldn't hit the result, shouldn't be important. Nevertheless, the model set had a lot of problems to handle these no hope questions. And as you can see, there was a performance hit also on bigger models. So always remember that they have generalized concepts, but on harder tasks, they can always produce hallucination and yield something that is not senseless. What the really interesting they have seen is that for some models, and interesting for small models, adding such phrases instead of hitting the performance, improve the performance. And this is really something that even the paper was not able to explain. So I think that about AI, we are really a lot to see. As of now, we will see the best is yet to come, and we have a lot of things to see. So this is to make you see that smaller models yes, can not be the right models to use for coding or hard tasks. But that's it. Read the paper. It's really interesting to understand how the models are performing. Okay, so let's switch to the practical things. So AI tools. The first tool I will present to you is Open Web UI, and this is really an important tool. Why? Because it allows you to run all the models you like with light LLM, and also allows also integrate itself with Ollama that allows you to run local models locally, and is highly customizable. So what is the point of using it? I will show you just an example. I was dealing with Raptor, that is an interesting framework to improve retrieval augmented generation and retrieval augmented generation performance. And I was looking at its implementation, but I really didn't like it. I wanted something, better. And so I use the open this tool because it allows me to implement a function that has this documentation. I wrote the documentation of the function. I give some function as assume these functions are already defined. I didn't want the model to focus on them. And what did I do? I used different models because Open Web UI allows you to run the prediction many times. Do you see here? It's small, I know, but here you can see 1 of 4. When you hit regenerate the answer and you select on the top left a different model, Open Web UI will produce another answer, and then you can switch between different answers and keep only the answer you like the most, and then continue along that answer. I will show you then another example that is more, well, I will do it now. This is a project that I am building a forensic dataset of images for a project I'm doing, and I will show you the overview. So I started from a prompt. This is the first one. I continued a bit, and then I've generated three different answers with 3 different models. Gemini, a local models that I will show you later, and O1 Mini. I took the first answer that the one that I like the most, and then I tried to guide the models in 3 different ways. And the model gave a lot of different answers. I selected the best, the one I considered the best, and then I went on using continue the discussion to improve the models. And what is important here is that you are able to select the best models for each task. When I started using writing the code, I used the Anthropic Claude 3.5 Sonnet that I think it's not only me that I'm thinking it's the best model to write code. Okay. And then when I reached at a certain point where I was pretty satisfied with the code, I switched to Gemini, and not the production one, but the experimental version that was out just 6 days ago. And I find it really good, and I think that is not for the first stages of analyzing your problem. But when you have some code to start on, it's really good to improve it, and it's really good to understand what you need. And so I went on with that model. The nice part is also that it's free, because you are not billed to use Google experimental models. And then I went on. Another thing that I want to show you is local models, because always for the privacy point of view, because some of you may deal with code that is not allowed to go out of a VPN and so on. So this is QQQ, a model, Chinese model, but it's really nice because it's trained like O1, so it's trained to reason. This is a quantized version, because to run a 32 billion model, you would, at full precision, not full precision, half precision, you would need at least 74 gigabytes of RAM, of network card. But this quantized version is able to run also on my server, and I have an NVIDIA 4090, so it fits in 24 gigabytes of RAM, and it yields a really nice results. So I will give you this example. This is the function I told him to write. So it's really nice to work like this, because it's telling you the entire reasoning is following. So you can follow the reason and agree or not with him, and you can also be inspired by this reasoning process. So it's really interesting, because other models, they just give you a solution. For example, this is the reasoning process, so it's very long and very detailed and very nice. I will show you the Anthropic answer. The Anthropic answer is just perfect, because it yielded a recursive function that works out of the box. So it's a wonderful answer. Score 10 out of 10. But I need to spend time understanding it. I need to spend time to guess if this is what I wanted, and if it perfectly fits what I want. Because for sure in a prompt you can tell the model some instructions, what you want, but you will never unless you are really wasting 1 hour, you will never be able to state all your requirements, your precise requirements, and many of them you don't even know when you ask the AI your precise requirements. So Anthropic perfect answer, but sometimes you will maybe prefer more this kind of answer that starts with the function definition, then reason, then gives you some pseudocode, then works again, then gives you a refined function, more reasoning, more refined function, more refined function, more reasoning, and so on. And the really nice thing about OpenUI is that you can edit also the answer that the AI gives you. So consider that I'm not agreeing with the, for example, let's say that, okay, I agree up to this point, so I agree up to this pseudocode, but I don't agree for what the model has said later on. So I'm just able to select all this code, delete it, and write another message. Okay, I agree with you up to this point, but let's do it this way. So you can really reason with the model, and I think you can come to a more tailored result for you. And the best part is that this model, you can use it for free, and you can use it offline. Granted that you have a lot of VRAM on some NVIDIA card. Okay, so this was OpenWebUI. I don't know if someone has any question up to now. Otherwise, I will go on with another tool.
I have one question.
Okay.
Okay, you showed that it's possible to connect your model that was in the server you have to this OpenWeb UI. Is there a procedure to do so, or how do you connect your model to this web application?
Well, it's pretty easy because the OpenWeb UI is already running on a Docker server, on virtualized Docker server on my server, and you can have many connections. So this is Light LLM that provides access to the models. For example, I will show you here. So Vertex AI, OpenAI, Azure, Anthropic, Gemini, a lot of models from Gemini, OpenAI, and so on. And then it connects also to Ollama, so you can write the AP, or if you have a DNS service, the DNS name of the to connect to your Ollama server. And you can add as many OpenAI API connections that you like. For example, there is a model that is the Mistral Pixel 12 billions model that is not still supported by Ollama. So I added also a VLLM connection, since VLLM is able to run that model, and it offers a Docker container that provides you with OpenAI compatible APIs. So, and as you can see, you can add as many connections as you want, configure Ollama, and it's really nice because it allows you to delete models and fetch new models directly from here.
Thank you. And the other question I have was, when you told that we modify the result of the model, and then I didn't get how you tell the model, okay, I agree until here, and then so let's reason again about the output. If it's necessary to save, so you modify and save, and then he will start again. It will start
I will
again.
show you right now. So let's start from this question, really long question, and I will edit it. So let's say that, let's go a bit down. Okay, explanation. Let's consider that I don't agree for this part, for the solution, for the approach, final solution. Okay, so let's hypothesize that you agree up to this partial pseudocode. I've highlighted this code. I will just delete it. I can save it or save as a copy. That's more clever because you will have both the possibilities. As you can see, there is a new answer here. There were 4 before. So this is just the part I've kept from the solution. There is nothing more. And then now I can type a message and say, okay, let's go on, but be careful about this thing, be careful about this other thing, and so on.
Great. So very nice. Thank you for the answer.
Okay, you're welcome. So let's go on with another tool that is okay, sorry.
So you said you have a local model.
Yes.
You are training from the scratch, or
No, for sure.
Learning, or
no, that local model that I show you is QWQ, and is a model from the same trainers of Quen, the Chinese model. So this is I don't know if you have ever heard about Quen. It's a Chinese model, and the QWQ is another Chinese model from China, but you can just download it. It's featured in Ollama. You can just pull it, and that's it. You will have it. I will show you. Ollama, you have a lot of models, and there is also QWQ, and you can pull it in the size you prefer. And I've pulled the smallest one because it fits in 24 gigabytes, and you will need more memory for the other models.
okay, thank you.
You're welcome. And it's really nice because it's licensed under Apache 2 license, so you are really free to do with it whatever you want. Okay, let's go on with another tool that is continue.dev, and in my opinion, the best extension to help yourself with VS Code and IntelliJ. And how to get help for new code bases or new languages. I will just give you some examples from a project. I was exploring for a project of mine, the ChatVoot project. Okay, so it's really, I will describe it manually. I know it's really small, but no, va su VS Code. Vediamo se...
aggiungo un topic.
Sì, esatto. Vediamo se un attimo riesco a ingrandire. Ok. Okay, so I was dealing with the chat for a project on mine with ChatVoot application that is a messaging application. It's written in Ruby. I don't know Ruby, never used it. So I've asked the continue.dev for I wanted to know the project was MIT, or I don't remember if it's MIT licensed or Apache 2 licensed, but it has also some enterprise edition modules that are copyrighted. So I wanted to know where are those modules injected so I can remove them and just take advantage from the Apache 2 licensed project. And the point was those modules were injected in some very particular way, so I wanted to understand it. And in some messages, the AI was able to help me, and I would have wasted I don't know how many hours to understand this, because the answer was that there is an inject enterprise edition module that that prepends any module. So whenever a module is loaded, this module kicks in, and to do this is kind of prepended to the root module class. Yes, so module.prepend, this means that the root class module in Ruby is prepended itself with this specific model to inject enterprise components. So this means that all modules in the application gain the inject modules. And it was really hard to understand, and this really helped me. How? Because continue.dev makes you able to index all the code of a project. And if you ask to use the code base, it does like a retrieval augmented generation. So it retrieves from the database semantically all the snippets of code that can be relevant for your questions, and make the AI able to answer you even if the AI is not fed with all the project code that would be, even if not impossible, really expensive. So this is a really nice example. And another example that I want to show you. Oh yes, just a tip. The history of continue is really is not working at all. At least in IntelliJ, I've already opened a bug in their code base on GitHub, and someone also gave reason to me and said, yes, I also have this problem, and my chat history is completely empty. And so I hope this will be fixed soon. But anyway, since here when you send a message, you don't have any history of different answer, I'm always using OpenWebUI for the initial brainstorming process, because it allows me to compare answer and so on. Another thing I want to show you is, yes, I don't know how I am with the time. I think I'm running out of time. So I just synthesize it for you. The point was I am working with the open source projects of LiveKit, because I'm working on a project that I was telling, something I hope to announce soon, for live speaking of connecting voice mode and AI to voice and to voice interaction for calling, for conferences and so on. And I had a problem with the LiveKit agents code, because there was a bug, and I wanted to improve the code. And also in this case, continue was really helpful, because I gave the entire context, and it was able to help me. Continue is very nice instead of Copilot or other mainstream tools, because you can, yes, I want to stress this point. The best thing in Continue is that you can have a precise control of the context. If you need to include entire files, because you know that the AI needs the entire file to give you a correct answer, you are able to do so. So in that case, in this history here, I included all the open files, and the files that were connected with what I wanted to do, and the AI was able to give me the right suggestions to add the functionality I wanted to add, without having me understanding the whole code base. So this was also really nice. Ask question, I already told you so. Get help writing code, yes. Editing code. There is also an edit mode of continue. So if you select some code, kind of this, and you hit edit, you can have something like this. And you can accept or reject the changes. So this is really nice. And you can always select the model. And this to me is very critical, because I always want to use the model that I know is best for that use case. Okay. And soon they will integrate some agentic functionality thanks to Anthropic Model Context Protocol. That is an open source protocol to make the AI interact with some tools you can provide. In this case, I will give you an example. If you select a cloud model here, tools will appear, and tools are like, come on, okay, create file, create new file, and so on. So you can avoid having to ask the AI to produce some code and then apply it yourself. This will help you do things really faster. Also, web search is important because sometimes the AI needs to refer to code base, to documentation to know what to do. View diff and currently open file and so on. So I think this will be a killer feature. It isn't implemented yet, but I am really waiting for it. And that's it. And the time is running, so I will just mention OpenHands. That is the best open source tool to do automated software engineering. And keep an eye on SWE bench, because it's the leaderboard for that tracks all the automatic software engineering tools. As of now, OpenHands is the best one. It's beating also Amazon Q solution. And it's open source. And I really love this about open source because it's amazing. Okay, and I prepared some bonuses if I had more times, but I think I've already run out of all the times I had. So thank you for having me. And do you have any more questions?
I think like curiosity to I have to press or it's already on. I mean, the first thing, does it give you a code like a commented code or normal code? And the second thing is it easily understandable? I mean, the code you are generating using the models, or?
Sure. Yes, to both questions. So the code it produces is perfectly understandable, and it always, if you take the lead, as I was suggesting, if I take the lead, you can ask follow-up question, and it will give you snippets of code, and so you can understand each snippet and insert it if you like it. For example, this is an example, because let's design a terminal implementation that takes into account many different things. So it started by telling me, okay, add this one to this class, reseton. So the conversation was like this because at the beginning I stated always ask for my confirmation, because before going on, let's plan together and so on. But if you if you practice this, yes, the outputs will be very understandable and very useful, and also inspiring. And that's the main point, because you are in charge of understanding what you are doing and creating the best software according to your experience and your know-how. So AI just helps you, but you have to start from a value-added process.
Thank you.
You're welcome. And just a few words. I really hope to announce some projects soon. So if someone is interested and if you like those projects, you may contact me, because in the near future I might need some help for some projects. So, and that's it.
Okay. Are there any other questions?
Maybe one more question. I mean, like,
You're welcome.
Because you told me you use the UNet for segmentation. Have you tried another models like SAM2?
We did, we actually did, and we also tried like, so I mean, thing is that results are promising. You need loads of fine tuning, especially with like the general purpose models. And whereas UNet already comes with many other models which have been pre-trained on medical images because UNet was meant at the beginning for medical images. What we'd like to explore a bit more now is some 3D approach, which takes into consideration the fact that when you actually take a video of an ultrasound, even if you're actually moving with the probe, for example, what you do is still trying to get inside volume of the mass of the organ you see. And so using like a 3D approach may also help you take into and exploit the information that comes from spatial and temporal because you're actually tracking, right? And so that's another approach I would like to do. But I mean, can I be honest with you? Extremely interested from an R&D point of view, extremely interested from what we call a playground point of view. What happens is as well that I need to, when I have some results that I'm happy with, okay?
They are not hearing you well from home because
the audio was deactivated. So the question was other models compared to UNet, and we tried some other like general purpose models, but with UNet it's much easier somehow because it already comes with other like pre-trained models on medical images because UNet was basically meant for that. That's what I was saying. And so the idea is that new approaches, especially when it comes to generative AI, let's say, are a bit harder to test and validate. So from an R&D playground point of view, from like, creating the next big thing, whatever, they all are quite amazing. But when you're actually developing a product, you also need to take into consideration the fact that I need to certificate this process. And so I really need to test, validate, and deploy a model which is safe and secure. And so consolidated models like UNet are also something that is being used for ages now. So also the regulatory bodies are, more acquainted to it. And this one thing. The other thing is that I need people to pay to use my product. And so I need to have something which is sustainable also from an economic point of view. And at the moment, some approaches are still not super sustainable. They would be very costly also in terms of deployment and maintenance. And so as long as performances allow me, and especially the doctors, to make their job, you can actually stick to that for a while, but definitely we'll actually explore in a lot.
Okay, thank you.
Okay, great. I think there are no any other questions. Otherwise, we can ask questions just after this speech. So we are okay. So yeah. So one moment. Okay, questions we have done. Then for the next meetup, we will meet on Thursday, 27th of February, each time of today, so the 7 p.m. If you have, again, any proposals for other speech, you can scan this QR code and fill the form. And that's all. We are happy to have you here and the online people connected now. And yeah, goodbye and see you the next time, hopefully in person.